So I want you to keep this idea of keeping things in balance, because today we are going to be talking about chemical equations, and that we react things together and we produce products, right? So you have the reactants on one side and the products on the other side, and that this chemical reaction kind of moves forward in this direction so that those reactants yield or produce products. Okay, so I want you to keep in mind that the chemical equations are all based on this law of conservation of mass, which I've tried to visualize here. Okay, so let's keep that in mind as we get a little bit more scientific, if you will, in our explanation about what is a chemical equation. It's also called a reaction equation. So remember that the one thing that I wanted you guys all to do this semester is I told you that I wanted you to be able to predict what would happen if you combine one substance with another substance. I wanted you to be chemists. I wanted you to be able to predict that. Okay, so let me say, I don't know, is there anybody out there, would you know what would happen if I gave you a pile of nickel 2 chloride and I asked you to combine that with some sodium hydroxide? Could you predict what would happen? And maybe you're like, oh man, Mr. A, I mean, I have no idea what you're talking about. I mean, I barely know what nickel and chlorine and sodium, and I don't even know what hydroxide is. And I'd say, well, you know what? Yes, you do. Yes, you do. If you would just take a minute and review what we had been talking about in the last unit, you would recognize this as the name of a compound, and you might even recognize it as a type 2 compound because it has a Roman numeral here, right? And so you can say, well, I can look up nickel on the periodic table, and there's a 2 in Roman numeral, so I know it has an oxidation number of a +2, and I certainly know what chlorine is. So there's some there's chlorine, and it is the anion. So, and I look it up on the table, and I know that it has a 1- oxidation number, right? And you also know that sodium is a group 1 metal, so it has a 1+ oxidation number, and you would recognize the hydroxide ion is a polyatomic ion, and it looks like this, so it's OH negative. So all we've done is we've taken the names and turned those into formulas, okay? So what I'm doing is I'm beginning to write a chemical equation. These are the reactants. These are the things that are going to mix together, and we are going to produce some products here on this side, okay? So let's take a look pictorially at what that might be. Now, I know these drawings are a little bit small, but I have a nickel particle right here, and I've got some chlorine particles here. Now, wait a minute, why is there 2 chlorine particles there? Oh, well, that comes from, you know, if we were to continue our strategy of writing the formula from this name, you would recognize that, hey, nickel with a 2+ ion, you're going to have 2 chlorines to match up with that, right? So if we did our upside down T-chart, that would be a 2+ on this side and 2- on this side in order for it to balance. And then we could actually write our equation as a NiCl2, right? The 2 coefficient on chlorine means that you got to have 2 of those particles. So here's pictorially what that would look like, right? Okay, now the formula for sodium hydroxide, well, that's actually looks like a match made in heaven, doesn't it? Because the sodium has a 1+ oxidation number, and the hydroxide ion has a 1- number. So we write the formula for sodium hydroxide as an NaOH. Okay, now pictorially, that's what that would look like. Here's the hydroxide ion. It's this is actually like a little covalent ion because we have a nonmetal hydrogen and a nonmetal oxygen. They're bound together, and then we have the sodium particle over here. So, okay, let me make a little bit better use of my space on my board. Stand by just a second. We don't need the long names of those two things anymore. But I do want to keep my formulas up there, all right? Because we are writing chemical equations, and I told you that we are going to start out with nickel 2 chloride, and we want to know that this says equations, right? So you would expect me for me to write an equation to come up with my products over here, right? But chemical equations don't use an equal sign. They actually use an arrow, okay? They use an arrow. And the reason we use an arrow is because it indicates that the reaction is going to go forward in this direction from reactants to products, okay? And that arrow, when we say the arrow, we say that arrow, when we say it, it's it yields or produces. So nickel chloride and sodium hydroxide produce products, and those are the products that we are going to predict what products we're going to produce. Okay, so that's kind of where we're at right now. Okay, so let's figure out. Well, you know, I'm not going to spend too much time on figuring out why this happens, because I really just need to tell you what a chemical equation is. So we've kind of dealt with this half of the equation. I still call it an equation because remember, we need to conserve mass. So the amount of mass that we have on this side has to equal the amount of mass that we have on this side. That means that we need to have as many particles of nickel on this side as we do on that side. Now, without telling you why so much this happens, I'm just going to tell you that this is what happens. You will be able to predict what kind of products you have, but that's a whole nother lesson. Suffice to say that if you mix nickel chloride with sodium hydroxide, you are going to get sodium chloride and nickel hydroxide. Okay? Now, even the untrained eye can tell you that, okay, well, I've got sodium and sodium, hydroxide, hydroxide, nickel, nickel, right? And even if you're a little bit more clear on what's going on here, you will see that actually some things have just traded places here, right? The chlorine has kind of swapped partners, you will, between the sodium and the nickel. And hydroxide is partnering with the nickel, and the sodium now is with the chloride. So you can see how things have kind of switched up here. But that's the way that's what happens when you have a chemical equation. It just turns out that the nickel would rather be with the hydroxide, and the sodium would rather be with the chloride. So that's in this particular reaction, they swap partners, if you will. Okay. So what does this look like pictorially? Well, here is sodium and chlorine. So there's the sodium ion and the chlorine atom. And here is nickel and hydroxide. Okay. Now, why did I have to put these parentheses over here? Well, we knew that nickel had a positive oxidation number of 2, and the hydroxide ion was only a -1. So you actually need 2 hydroxide ions to partner with that one nickel. Okay, so again, you kind of have to rely on what you were learning before in order to write this. But if I told you that I want you to write the formula for nickel hydroxide, you could do it because you know what the oxidation numbers is. So when I write the formula like that, that actually means that I have to have 2 hydroxide particles for every 1 nickel. Okay, so this is the chemical equation for this reaction, but there's a problem with it. Does anybody see what the problem is? If any of you had a science class before where you had to balance chemical equations, you might be asking yourself, is this equation in balance? Now, what do I mean by that? Does the equation satisfy the law of the conservation of mass? Well, I've got one nickel over here, and I've got one nickel over here. I've got one sodium over here, and I've got one sodium over here. I've got one hydroxide ion over here. I've got, two hydroxide ions over here. What happened? Did hydroxide ions just kind of magically appear? Well, what about these chlorine ions? I got chlorine ions over here, two of them, but I only have one over here. Did they just magically disappear? Did one of those just magically disappear? No. That can't happen. So you have to balance the chemical equation, right? So because the chemical equation has to obey the law of conservation of mass. Okay, so real quick, here's how we do that. Let's just say that I want to, let's just start with nickel. Okay, nickel's in balance, I don't have to do anything with that. Let's start with, then second up is chlorine. All right, I've got two chlorine over here. See, there's the subscript 2 chlorine over here, so I need 2 chlorine over here. There's something that you can do to balance a chemical equation. It's called adding a coefficient. You can actually put a coefficient of 2 in front of the sodium chloride, and what that does is it multiplies everything that follows that in this term by 2. So now I have 2 sodiums and 2 chlorines, all right? So there's my 2 chlorines, and there's my 2 chlorines over here. So as far as the chlorines are concerned, they're in balance. Am I done balancing this equation? No, because the eagle eye among you will say, well, Mr. A, if you multiply everything by 2 in this term, then you're multiplying the 2 sodiums. You've got 2 sodiums on this side, you're going to have 2 sodiums on this side. Okay, all right, so why don't I just put a coefficient of 2 over here? So here's another coefficient for 2 right there. And pictorially, I'll have to add another picture so that I have 2 sodiums over here and 2 hydroxide ions, okay? Just remember, these are called the coefficients. I haven't changed any subscripts. I haven't changed the compounds themselves. I've just put more in the equation, okay? Okay, now let's check and see if we're balanced, all right? So I got 1 nickel over here. I got 1 nickel over here. I got 2 chlorines over here. I got 2 chlorines over here. I got 2 sodiums over here. I got 2 sodiums over here. I got 2 hydroxide ions over here. I got 2 hydroxide ions over here. The chemical equation is balanced. And the way that we had to do that was first you write the compounds correctly, and then we had to have the coefficients, okay? Reactants on this side, products on that side. That's pretty much everything that you need to know about what a chemical equation is. We're going to have a whole lesson on how to balance them. I know I did that really quick, but we're going to have lots of practice on that. And yes, we will eventually get to learning how to predict what the products are. That'll probably be the last thing that we learn this year. Okay?